Welcome everybody once again. So this is our 13th class for module 3. We are studying flow through pipes. So losses, the major losses and minor losses. So last class we saw some 5 problems related to these losses. Today we will see some 3 more problems. Okay. So next problem is the rate of flow of water through a horizontal pipe is 0.25 meter cube per second. So your pipe is horizontal and the rate of flow of water through this horizontal pipe is 0.25 meter cube per second. Now the diameter of the pipe, which is 20 centimeter. So the diameter of the pipe is 20 centimeter, which means it is equal to 0.2 meter, is suddenly enlarged to 40 centimeter. So this pipe is suddenly enlarged. So it is suddenly enlarged. So we will take this as a D1. So D2 suddenly enlarged to 40 centimeter, which is equal to 0.4 meter. The pressure intensity in the smaller pipe is 11.772 Newton per centimeter square. See, that means we will take this smaller pipe. We will take section 1 in the smaller pipe and section 2 in the larger pipe, which means P1 is equal to 11.772 Newton per centimeter square. That is equal to, in order to convert it into Newton per meter square, we have to multiply it by 10 raised to 4. So 11.772 into 10 to the power of 4 Newton per centimeter square. So these are the given things. So we will write. So first of all, discharge is given as 0.25 meter cube per second. D1 and D2 is given. So D1 is equal to 20 centimeter, that is equal to 0.2 meter. And from this we can obtain A1. So A1 is equal to, that is area 1, A1 is equal to pi into D1 square, that is 0.2 square divided by 4, pi D square by 4 or pi R square. So we get A1 is equal to 0.03141 meter square. Similarly from D2. So D2 is given as 40 centimeter. So that is equal to 0.4 meter, from which we get A2 area at section 2 is equal to pi D square by 4. So pi into 0.4 square divided by 4, that is equal to 0.12566 meter square. See, the diameter is greater diameter will have greater area. So you have to just see, for simple, if we do any calculation errors, you can just identify from this. Okay, if you are doing any mistakes here, just to check whether this area is greater than this area. So small errors you can avoid in the early stage itself. Now the pressure P1 is given, pressure intensity in the smaller pipe. So P1 is given as 11.772 Newton per centimeter square. So in order to convert centimeter square to meter square, we have to divide it by 10 raised to 4. So it is per centimeter square. So we will multiply it by 10 raised to 4. So 11.772 into 10 raised to 4 Newton per centimeter, Newton per meter square. So now, see, from these two, we know the discharge and area. If we know the discharge and area, by applying the equation, continuity equation, we can find the velocity. So our continuity equation is Q is equal to A1 V1 is equal to A2 V2. So we can equate Q and A1 V1, we can equate Q and A2 V2. Okay, so equating Q is equal to A1 V1. So from this what we get is V1 is equal to Q by A1 and V2 is equal to Q by A2. So substituting the values of Q and A1. So V1 is equal to Q is 0.25 divided by A1 is 0.03141. We get V1 is equal to 7.96 meter per second and V2 is equal to Q by A2. So 0.25 divided by A2 is 0.12566. We get V2 is equal to 1.99 meter per second. Now, we are asked to find the loss of head due to sudden enlargement. First is loss of head due to sudden enlargement. So, how will we determine that? We know the formula for loss of head due to sudden enlargement is equal to V1 minus V2 the whole square by 2G. So now what is V1? V1 is 7.96 minus V2 is 1.99 the whole square divided by 2 into 9.81. We get the losses due to sudden enlargement as 1.816 meter. Now the second case, pressure intensity in the large pipe. So we need to find P2. P1 is given, we need to find P2. So pressure intensity in the large pipe, that is second, we need to find P2. So in order to find P2, we will apply the Bernoulli's equation. Bernoulli's equation is P1 by rho G plus V1 square by 2G plus Z1 is equal to P2 by rho G plus V2 square by 2G plus Z2 plus here the losses is losses due to enlargement. See now it is horizontal, right? So since the pipe is horizontal, since the pipe, sorry, see I can show it here. Since the pipe is laid horizontal, you draw the center line. So this can be taken as our reference line. So Z1 and Z2 remains the same. So Z1 is equal to Z2. So if Z1 is equal to Z2, you can cancel this Z1 and Z2. Now P1 is known, right? P1 is 11.772 into 10 raised to 4. Rho is the flowing liquid is water. So density of water is 1000. Here 1000 kilogram per meter cube. Okay. So density is 1000. G is 9.81. V1 we have already determined it as 1.99. Again G is 9.81. P2 is unknown. So the only unknown is P2. We know all the remaining values. We know what is rho G, V2 square. V2 is 1.99. V1 is 7.96. Okay, V1 is 7.96. Plus HE is also determined as 1.816. So the only unknown is P2. So substitute all the values. We get P2 is equal to 12.96 into 10 to the power of minus 4 Newton per meter square. So that will be equal to 12.96 Newton per centimeter square. Okay. Now we have to, what is the third thing we need to find is pressure lost due to enlargement. So the pressure lost due to enlargement, that is our third thing what we have to find. So as we have discussed in the previous problem in the last class, the pressure lost due to enlargement will be equal to weight density, that is rho into G. weight density multiplied by discharge multiplied by the head lost. We will get the power lost in terms of watts. In order to convert it into kilowatts, we will divide it by 1000. So what we get is 1000 into 9.81 into Q is 0.25, HE is 1.816 divided by 1000. We get the power lost is equal to 4. That is power lost due to sudden enlargement will be equal to 4.453 kilowatts. We will move on to the next problem. So the next problem is a horizontal pipe of diameter 50 centimeter is suddenly enlarged, is suddenly contracted to a diameter of 25 centimeter. So we have a 50 centimeter pipe. So here D1 is equal to 50 centimeter. So that is equal to 0.5 meter. It is suddenly contracted to 25 centimeter. So D2 is equal to 25 centimeter, that is equal to 0.25 meter. The pressure intensities in the large and smaller pipes are 13.734. So P1 is equal to 13.734 Newton per centimeter square and P2 is given as 11.772 Newton per centimeter square. Okay. The pressure intensities in the large and smaller pipes are given as 13.734 Newton per centimeter square and 11.772 Newton per centimeter square respectively. Find the loss of head due to contraction if Cc, that is coefficient of contraction, is given. You need to find what is the loss of head due to sudden contraction. Also determine the rate of flow of water. We need to find what is Q. So, what are the given data? D1 is given as 50 centimeter. So, that is equal to 0.5 meter. So, from which we get A1 is equal to pi d square by 4. So, substituting we get pi into 0.5 square divided by 4. So, A1 is equal to, we get 0.1963 meter square. Now, diameter of the smaller pipe can be taken as D2. So, D2 is equal to 25 centimeter. That is equal to 0.25 meter. And from this we get A2 is equal to pi d square by 4. D is D2 here. So, pi into 0.25 square divided by 4. We get A2 is equal to 0.04908 meter square. Now, the pressure intensity in the larger pipe is given as P1. P1 is given as 13.734 Newton per centimeter square. So, converting it into meter square, we get 13.734 into 10 to the power of 4 Newton per meter square. And P2 is given as 11.772 Newton per centimeter square. So, converting it into meter square, it is 11.772 into 10 to the power of 4 Newton per meter square. Then what else is given? The coefficient of contraction is given. Coefficient of contraction is given as 0.62. So, Cc is given as 0.62. See, while discussing the theory part, I forgot to tell you one thing. That is, see, while explaining the losses, minor losses. So, in order to determine the losses due to sudden contraction, I told you the formula is HC, that is head loss due to sudden contraction, is equal to 0.5 V2 square divided by 2G. Yes, this is correct. But this is correct when you know V2. Now, if V2 is not known, if the coefficient of contraction is given, the formula is, I forgot to tell you this formula. If the coefficient of contraction is given, the formula is HC is equal to V2 square by 2G. Okay, the same thing, V2 square by 2G. And this constant is actually, it is 1 by Cc minus 1 the whole square. So, if the value for coefficient of contraction is given, you have to use this formula. If coefficient of contraction is not given, you can use this formula. Okay. So, this is the formula for determining the coefficient losses due to coefficient of contraction. So, now we need to find the loss of head due to coefficient of contraction, and we need to find the rate of flow. We need to find these both. So, first of all, we will find what is loss of head due to contraction. Because Cc is given, we will use this formula, that is V2 square by 2G multiplied by 1 by Cc minus 1 the whole square. So, we get V2 square by 2G multiplied by 1 by Cc is 0.62 minus 1 the whole square. So, we get 0.375 V2 square by 2G. Now, we will apply the continuity equation. So, by applying the continuity equation, so we know what is the continuity equation? Q is equal to A1 V1 is equal to A2 V2. So, now we will equate these both. So, equating these both, we can get V1 in terms of V2. So, from this we get V1 is equal to A2 V2 by A1. So, substituting, we get A2 is pi D2 square by 4 into V2 divided by A1 is pi D1 square divided by 4 into A1 is pi D1 square divided by 4. So, we get V1 is equal to V2 divided by 4. Now, we can apply the Bernoulli's equation. So, Bernoulli's equation we know P1 by rho g plus V1 square by 2g plus Z1 is equal to P2 by rho g plus V2 square by 2g plus Z2 plus the losses. Here the losses is due to contraction. So, what we get is P1 is given as 13.734 into 10 to the power of 4 divided by rho is 1000, G is 9.81. See, the pipe is laid horizontally. So, Z1 will be equal to Z2 plus V1 square. So, V1 square will be equal to V1 square is V1, we have already calculated it as V1 is equal to V2 by 4, right? So, V1 is V2 square divided by 4. V1 is V2 divided by 4. So, V2 divided by 4 the whole square divided by 2 into 9.81 is equal to P2 is given as 11.772 into 10 to the power of 4 divided by 1000 into 9.81 plus V2 square divided by 2G plus HC. HC we have calculated it as, see HC we have calculated it as 0.0375. 0.375 V2 square by 2 into 9.81. So the value for G is 9.81. Now you see the only unknown is V2. So from which we get V2 is equal to 5.467 meter per second. Now we can find what is HC and what is Q. So what is HC now? HC is equal to 0. See this value 0.375 V2 square by 2G. So which is equal to 0.375 into V2 we have determined as 5.467. 5.467 square divided by 2 into 9.81. So HC is equal to 0.571 meter. Now we have to find what is discharge Q. So we know discharge Q is equal to A1 V1 or A2 V2. So we have already found what is V2. Therefore, we use the formula Q is equal to A2 V2. We get, substituting the value of A2 and V2, we get Q as 0.2683 meter cube per second. So in order to get it in liters per second, it is equal to, multiplied by 1000, you get 268.3 liters per second. We will move on to the next problem. So next problem is, water is flowing through a horizontal pipe of diameter 20 centimeter at a velocity of 3 meter per second. So the flowing liquid is water. The flowing liquid is water. It is flowing through a horizontal pipe of diameter 20 centimeter. So D is equal to 20 centimeter, that is 0.2 meter at a velocity of 3 meter per second. A circular solid plate of diameter 15 centimeter is placed in the pipe to obstruct the flow. So there is a circular solid plate, right? So there is a circular solid plate in the pipe in order to obstruct the flow. So this diameter of this pipe is 15 centimeter. So this diameter is 15 centimeter, that is 0.15 meter. Find the loss of head due to obstruction in the pipe if Cc is equal to 0.62. See here Cc is equal to the coefficient of obstruction. Coefficient of obstruction is given as Cc. Okay. Now, so the given data are D is given as 20 centimeter, that is equal to 0.2 meter, from which we can find the area of the pipe. Area of the pipe is pi D square by 4. We get pi into 0.2 square divided by 4. So area of the pipe is equal to 0.03141 meter square. Now, diameter of obstruction. We will find what is the diameter of obstruction. So, this diameter of obstruction is, diameter of the obstruction is, you can take D1 or like that, okay. Take it as D1. So diameter of obstruction D1 is equal to 15 centimeter, that is equal to 0.15 meter, from which we get area of the obstruction as pi D1 square by 4. So pi into D1 is 0.15 square by 4. So area of obstruction is equal to 0.01767 meter square. See, always remember this area of obstruction is always less than the area of the pipe. Now, what else is given? CC is given as 0.62. Now, the head loss, the formula for head loss due to obstruction is, head loss due to obstruction will be equal to V square by 2G multiplied by A by Cc into A minus 1 the whole square. So A is known, small a is known, Cc is known. We don't know what is the velocity. Velocity is given as 3 meter per second. So velocity is also known. Here velocity is given as 3 meter per second. So just to substitute the values. So V is 3 meter per second. So 3 square divided by 2 into 9.81 multiplied by area of the pipe. A is 0.03141 divided by CC is 0.62 into A is area of the pipe, that is 0.03141 minus area of obstruction is 0.01767 minus 1 the whole square. So you calculate, you will get the head lost due to obstruction as 3.311 meter. So that is all for today. So see, for other cases also, that is head loss, we have studied some other head losses also. That is we have studied head loss due to bent in pipe also. So see, if such problems are asked, you can just substitute the formula which we have studied in our first class, that is day before yesterday, and you can substitute and you can take the answer. I have given you the problems for major losses using Darcy-Weisbach formula, for using Chessie's formula. Then we saw some problems related to loss of pipe due to sudden enlargement and loss of pipe due to sudden contraction and obstruction. If any other cases are also asked, you can use the formula and you can find the answer. Now, in the next class, we have, in order to complete our third module, we have more problems. We have two more concepts. That is, we have already studied the concepts, hydraulic gradient line and total energy line. So problems related to this hydraulic gradient line and the total energy line, we will see it in the next class. And after that, we will see the horizontal pipes, problems related to horizontal pipes laid horizontal and in series. Sorry, pipes laid in series and parallel. So with that, our third module will be over. So that is all for today. Next class, we will continue with the problems related to hydraulic gradient line and total energy line. Thank you for listening. Thank you.